Hello everyone and welcome back to another video. Today I'm going to be doing a walkthrough of the tutorial. I did this once before, but I don't think I actually did it with the actual tutorial per se, or maybe did I can't remember actually, but we're going to do it again. Alright, so let's start out with sort of the movement part. And I personally switched to X so I can just move based on where my mouse cursor is located. This part we'll just walk you through getting glucose, ammonium phosphate. Here's the ammonium phosphate one. I'm probably going to go more over things with the editor. And read actually what the various parts actually do. I'm now going to hit J to go to the double speed option. I've generally been using this when I make the videos so that the videos are not too long. Be careful of the radiation chunk, which I was not careful of at all. Alright. This is interesting. That's showing me all that. I think usually you would just send you right to here with the tutorial. I've tried this twice before. One time I don't think I was recording. The other time I started getting a bunch of errors. Alright. So we're going to act like it's being normal. Alright, so this is the microbe editor, where you can evolve your species by spending mutation points. Each generation, you will always have 100 mutation points to spend, so don't bother saving up. The hex in the center of your screen is your species. It is a simple microbe for now. To continue, select a part from the left panel, then left click again to the hex next to the hex to place it. You can rotate parts with A and D. A safe first evolution is to add 1 to 2 pieces of cytoplasm or hydrogenase to your species. Now then, I tend to do something a little differently when I do it. But there's some more tutorial stuff, so put that down. So we can talk about moving organelles also costs MP, as it is a mutation to your species, unless they were placed in the current editor session. You can right-click organelles to bring up the organelle menu and select the delete option to remove them. If you made a mistake, you can undo any change you make in the editor. Click the undo button to continue. When selecting parts, pay attention to the tooltips to understand what they do. Parts can do more harm than good if you don't consider their function. Each part requires maintenance, called osmoregulation, and some of them run processes that require certain compounds to function. These can also be seen in the organism statistics panel. Additionally, the more parts you add, the more compounds you'll need to reproduce, making it take longer. Press the redo button to continue. Alright. Of course, not more. Adaptation is hard. There are many sources of ATP, but not all of them are usable everywhere. You can use all the tabs and panels here to make the most informed choice you can, or just try something and see how it works. Just remember, if you don't make enough ATP, you won't survive. A lifestyle finding glucose and turning into ATP will work for now, but naturally occurring glucose will decline every generation. As a finishing touch, you can rename your species by clicking on the name on the bottom left and editing the text. So some other things I want to talk about is there is a symmetry button here. This is actually what caused the errors start popping up in my first attempt at recording this, and I stopped because I didn't want to have that result in some kind of issue. But there's a double, quadruple, and then like a 6 symmetry thing, but it's generally not usable in the microbe stage given the general cost of the parts. In the later stages, potentially even somewhat into the current early multicellular that we're starting to work on, or even the macroscopic stages, that symmetry will become more useful for editing individual cell types, as the cost will probably be very low at that point, that you can reasonably do just a symmetry of like 6 things around a cell. Also does depend on how the cell itself is designed. Do that for now. I can spell with my keyboard. There we go. So to go over what currently there is in the structural tab here. Also, if you notice, I kind of minimize these two. I'm going to do that a little bit later. But in structural tab, we have the cytoplasm, which takes 0.009 units of glucose and turns into 2.5 units of ATP per second. It has a 0.5 storage increase and a 0.9 osmoregulation increase, and an additional cost of ammonia and phosphate of 1 each. And then all the proteins have the same storage and cost addition, so I'm only going to go over their actual effects after the hydrogenase one. So hydrogenase takes 0.013 units of glucose and turns it into 4 units of ATP per second. Storage is an additional 0.25. Osmoregulation cost is plus 0.9. The ammonia cost is plus 1, and phosphate cost is plus 1. And then the chemosynthesizing protein, it does glycolysis of 0.006 glucose per second. Not glucose per second yet. 0.006 glucose to 2 units of ATP per second, and chemosynthesis of 0.193 units of hydrogen sulfide to 0.193 units of glucose per second at 43.5% carbon dioxide. Then restosiren takes 0.055 units of iron to produce 5.5 units of ATP per second. And the thermosynthase takes 4 degrees Celsius of temperature and creates 0.02 units of glucose per second. I believe that this does increase for, this is basically, I think, so if it's 8 degrees Celsius, I believe it's going to produce 0.04 units of glucose per second. I'm not entirely sure that's accurate, but I think that's how it works, code-wise. And then also does glycolysis of 0.006 units of ATP per second, 0.006 units of glucose to 2 units of ATP per second. All right. And then there's the membrane tab. I don't remember if the tutorial ever mentions this, so I'm going to go over it now. You can change your membrane type for 50 mutation points, and you always start with the normal membrane, which is basically like a animal cell membrane, double as bacterial, but each one will change your mobility, your resource absorption speed, health, and the overall osmoregulation cost of your organism. And then some will have additional effects, like cellulose will have an increase to physical damage, so like spikes will do less damage. And additionally, there are 3, including cellulose, that will not be able to engulf and can resist basic engulfment. Then chitin, it has a toxin resistance. Calcium carbonate is unable to engulf, but it can be engulfed normally. All right, there's only two that cannot be engulfed normally. I always think it's 3 because the lysosome has 3 different settings to it, but it's only cellulose and chitin that cannot be engulfed with base engulfment. You need a lysosome with a specific enzyme to engulf them. These 2 can be engulfed still. Sorry about that. Yeah, so calcium carbonate, it has a lower resistance to physical damage, but increased resistance to toxic damage and is unable to engulf. And silica has the reverse of calcium carbonate. It has an increase to physical resistance, but a decrease in toxin resistance, and it is unable to engulf. Then, obviously, you can change to fluidity and rigidity. Rigidity will increase health but lower speed, and fluidity will increase speed but lower health. And of course, you can change the color of your cell so you can see it or have some fun with that. And behavior, a lot of times I've noticed that making it sessile will actually down here, which doesn't show right now because we're in the tutorial, I guess, but this will actually for some reason increase your overall population amount. A lot of these other ones don't really seem to have that effect. I think they're trying to make sure they do, but last I checked, I haven't seen them actually take much of an effect. All right. Of course, I mentioned this in my previous take, but you can pause at any time. For example, to focus on a longer tutorial while pausing, you can also save interesting species you see with the fossilization feature, which is what this is. This was a feature added in after some time, but you can hit that well, actually, I don't know it's the name, but you can hit this to phosphorus. I've actually done that before, so I'm gonna pull up my Thyvopedia to my museum. Of course, these are all outdated, but these are ones I've done. Also, these are from my challenge of making spore cells in Thrive. I do plan on making some more of those, but I've only saved that one from the other recent dudes. Oh, that's I should have thought about that. um, yeah, so that's how all these are here. I think that was just a purple hex cell that I saved there. But a lot of these were the previous playthroughs I did and some other stuff. I think there's 3 of these I think were for my Spec Evo project. Yellow plant cell, green plant cell, red algae. But I think that one looks like it was iron. That was a photosynthetic cell. That was just spikes galore. This one, I think was, looks like it's thermosynthase. That one I see, I actually see what those are. I'm gonna look at things. I know one of the ones I had was toxin oriented, but then I went into the multicellular to show off the different toxin modes. Which, that might actually be that one. Yeah, that one's the toxin one. Alright. Yeah, so that's what that does. Yeah, you can also hit this when it says pause, because the thing to note is hitting the other buttons here will actually pop up other menus, and then that's what your spacebar will actually continue hitting. Oh, now it wants me to try and engulf something. There we go. You just hit G to engulf. You do have to be bigger than the cell you're trying to engulf, otherwise you will not be able to do so. And if a cell of a different species is bigger than you, it has the ability to engulf you, as long as it is actually able to do so. Of course, you'll now also see that I no longer take damage in hydrogen sulfide because of the chemosynthesizing proteins. It's one of the reasons I would generally suggest making use of that when you're in these lower patches in order to not take constant damage. Alright, continue just reading the tutorial this way. In the process of growing enough to reproduce, each of your organelles will divide. These new organelles provide bonuses and osmoregulation costs just like the organelles your microbe started with. With time, organelles will start to duplicate. Collecting compounds speeds this up. Once all the organelles have divided, your cell can reproduce and enter the editor. Alright, so now we're seeing what normally would have popped up this time around. Welcome back to the microbe editor. We'll turn here after each time you reproduce. The report screen gives you a list of changes in the region you currently occupy. Try exploring the various tools at your disposal to learn more about events in your world. After reviewing what has happened, you can then make changes to adapt your species. When you're ready to do so, press the next button in the bottom right to continue. I'm going to go over a little bit more about this right now. So in the statistics tab here, we have a species population, and it will be color-coded based on the membrane color of different species. So, here we have ours at 0. The first, when you start the game, obviously you'll be the only one. 100 million years can be a handful of species from the initial speciation. And then, obviously, next generation, we can see we got a new species right here, which, just make sure, that one just makes sure this is new, and this is also new. But this one might actually be, let's just say in this patch, so that is, I don't see it here right now, because also it says global results there. Okay. It could be hidden over here, maybe. Yeah, so this will show the rise and fall of species populations, so you can kind of track that. It'll also show X's for species that are no longer in a certain patch area, and a skull if it's gone fully extinct. Then you have the atmospheric gases. This will go up and down at times. Obviously, oxygen right now, nothing. I don't think we'll be able to see it immediately, but obviously we're in one of the lower patches, so oxygen in general will not be much of a factor at this point. But nitrogen, hydrogen sulfide, nitrogen and carbon dioxide will sometimes just fluctuate over time. Then we have compounds. Okay. Alright, so obviously shows all your various compounds that are going on the patch. You'll see the glucose has been decreasing over time. It does continue decreasing. Uh, Phosphate and ammonia, pretty stable. Ammonia did go down a bit, and then iron went up a little bit, it looks like, or just stayed the same. Of course, the big change right now is this hydrogen sulfide one. So when we're able to see the actual patch map of the world, you'll sometimes see events that occur. And this right here, because I'm used to the game, I can tell you that this was the result of a volcanic eruption that happened within this patch that generated a lot more hydrogen sulfide in the last round that we were playing through, but it has decreased now as well. But that will give additional hydrogen sulfide in patches and whatnot. Then we have physical conditions, so like temperature and sunlight. Obviously, we're not going to have any sunlight. We're at the bottom of the ocean, and temperature is generally not going to change too much because we're also in the hydrothermal vents. Then back over to this area, obviously we see, looking into our patch, and I can also look through all these, but there's likely not much to really see. But obviously based on the current patch run, we'll see what's going on. The player cell, usually I'm pretty sure it's always in the left top corner, even when there's a lot more going on. Then you'll see other cells. You'll see increase or decrease in their populations, and also these indicators of whether or not they are new in this generation or if they mutated. And you see the global results down here. So you also see overall results that way. And then sort of reasoning, so by reproducing, you always have a decent population boost. And then any deaths, whether your deaths, I do believe, are, have more of an impact on your population, but the deaths of the other cells of your species will also affect it, but they will do so slightly. So you can see all that in there. There is a food chain button. I have tried to figure out this somewhat still at times because I'll see weird connections, but it'll show generally what different species are sort of focusing on for their metabolisms and lifestyles, and then overall timeline. This used to be what you would agree with before this auto evo panel was the prominent one. Yep, that's what I thought. Underwater vent eruption, right there, which is what explains that boost right there. And this is another way to see it. You'll see these pluses here. Up arrows for increased populations, down arrows for decreased populations, and it looks like some of the cells have actually moved into other the nearby area. The sea floor. Let's take a look at it. So if we do this, we'll now see panels have changed a little bit, and we'll now also see fewer species compared to the global results. And I think this may actually show everything. I'm not sure this is for patch or for everything you'll see there, but kind of see that as well. But things just moved here, so it's not a lot to actually look at. All right, I'm gonna hit next. The ATP production bar over here on the right indicates how much ATP your cell produces compared to how much is consumed. If the top bar is shorter than the bottom one, then you are not producing enough ATP. The bottom bar contains the osmoregulation cost and the movement cost. Osmoregulation is the base cost of staying alive. Every part you add increases this cost. You don't have to pay the movement cost when you aren't moving. If your ATP production is negative, be sure to increase ATP production or add storage to allow movement in bursts. And it will give a warning if your ATP production is lower than your overall ATP usage. So we do have a new part here. So this is a toxisome. It costs 55 mutation points. It does glycolysis, taking 0.006 units of glucose and turning it into 2 units of ATP per second. But it also gives us an ability, which is cytotoxin synthesis. It takes 3 ATP and turns it into 0.22 units of toxin per second. And this part also has variations to it. So I'm going to just kind of pop it and show that. So we're going to modify it. And here we'll see a panel. There's a few handful of parts that do this. One of the other ones is in the external tab, which also we just obtained this editor cycle. Uh, Detoxin will always start with cytotoxin at its base. There's various other ones here as well. You can change the fire rate and toxicity to make it less damage, but fast firing, or more damage, but slower firing. And these other ones will have different effects on how they're used. So the oxytocin damage is based on oxygen-using organelles, so things like mitochondria and the like. Acrolide that one lowers speed. This one basically makes a higher ATP usage for the cell that got hit by it. And cyanide, damage increased per oxygen-using organelle. So this one has lower damage and that stuff, while cyanide has higher damage. So this could be good for like things using the hydrogenosome and hydrogenase. While this one's good against the mitochondria and whatnot. But I'm not actually going to use it, so I'm going to do the undo. To show off what we got here, we have the perforated pilus, which is just, well, a spike. It does also have the ability to be modified to also an injector pilosome, which will actually do toxin damage. And I recall there being some other way that this could be like messed with, but I could be wrong. Alright. There's the chemoreceptor, another part that has adaptation modifications to it. This lets you modify it to look for certain compounds. You can change the line color, especially if you have multiple chemoreceptors looking for different chemical compounds. So of course, you also have to look for species, which is rather interesting. I've never actually used it for that specifically, but it could help for endosymbiosis. Of course, at all these, you can also look for mucilage, which is an interesting one. And then there's the slime jet. I would always say put it on the back if you're going to use it. It also is modifiable to a microcystis, which makes a membrane around your cell to protect it from being engulfed. But this creates mucilage to give speed boosts. And also, I did not. Also, the pilus is a 30 mutation point part. The chemoreceptor is a 45 mutation point part, and the slime jet is a 60 mutation point part. And it uses 0.002 glucose to create 0.2 units of mucilage per second, regardless of whether or not it has been modified or not. The modification will change what it actually does. For now, I'm going to just throw on the synthase and then arrest the siren. Of course, nothing to do here really at the moment, and nothing I would be doing there either. Alright. The gameplay counterpart to the editor ATP display is the process panel. It'll show a real-time display of how fast each biological process is running in your cell. You can think of your cell like a small factory that is consuming and producing different compounds constantly. Press the highlighted button in the bottom left to toggle the process panel open. Pause as well. So this is the process panel. You can monitor your cell processes in real time. The spinners show how fast a process is running, and the numbers show an averaged value of recent consumption or production. You are a small cellular factory that needs to constantly produce ATP to keep itself alive. If a number turns red, that means it is a limiting factor. For example, if a process that produces ATP has an input turn red, you'll be in big trouble and will need to find more of that compound before you start dying, which in this case is iron, because we just started, if we go here, we did just fill this up, but at the start we didn't have any iron, so it wasn't able to make any ATP at the moment. And here, we can see that hydrogen sulfide is in red, which likely means we do not have any hydrogen sulfide, so it cannot create any glucose from that at the moment. But everything else is looking good. The toggle buttons next to a process can be used to turn them off or on. These can be used for advanced gameplay tactics to try to figure out what happens when you run out of compounds. Try turning off one of the processes and then immediately turn it back on to stop dying. Note that the game will that the game needs to be unpaused. So, in order to show that off, I'm going to turn this off. Well, that's not enough to kill me yet. You can see how that affects things. I'm going to make sure that spacebar is matched up to that. Alright. But you'll also notice that speed has in fact slowed down as I've added more parts. You cannot keep your speediness as you get bigger, of course. Otherwise, I mean, it would make very scary situations even in real life if like a massive organism could run at terrifying speeds simply because it was bigger and didn't have some debuff because of its size and overall mass. So that is, of course, another thing that does have to be considered when you are playing. The bigger your cell is, the slower it will get, so it will become harder to catch smaller things. Alright. Microbe has successfully reproduced again, taking another step towards being a more advanced life form. The goal of the early game is to find a good patch to live in and a reliable food source there. Later on, you can start thinking about adding the nucleus, which is the way to advance in the game. But don't add it too early as it is a very expensive organelle. Press the next button to continue to the patch map. Of course, it's the first time that we will be seeing the patch map. And of course, once again, we can look what's going on here, and there's a species that is extinct from the patch there. You can see it's here well, but if we look at it on here, it is still present because it has a population established in another patch. So it is still present. When we hit next, we'll get the patch menu, patch map. Life started in a small corner of this world, right here. And I managed to make it go okay. But yes, this is a patch map. Depending on most of the games, especially if you're early, or if you're new to it, I would always suggest just starting in the volcanic vent, which is a base starting location. So you won't have to worry about much at all. It has hydrogen sulfide, high temperatures. You don't have to worry about dealing with oxygen really that much, or sunlight, or changing your pressure, temperature values at all. Of course, then we have these other patches where species have been moving into, and we can see over here if pressure decreases, or things, well, if these conditions, gases, or compounds increase or decrease by the arrows. So compared to ours, the patch next to us has lower temperature, same pressure, same light level, and more glucose, more iron, but hydrogen sulfide, ammonia, phosphate, and radiation chunks have all decreased. And of course, each different patch will have different characteristics and features. Like, this one will generally have more hydrogen sulfide present in it. Speaking of an eruption, this one currently has an eruption, so it's had a major boost in its hydrogen sulfide concentration. There are also meteorite impacts, which I do not know if any of them occurred in any of the previous summaries, but there are. But for the actual biome types, there is the volcanic vent, the sea floor, the bathypelagic, the mesopelagic. It starts to get a little bit of light level in it. Of course, a lot of these can be pretty similar, but we'll have slight changes in compound concentrations, pressures, temperatures, light levels. And here we have an ice shelf, so there will actually be ice chunks that can damage you here. It'll have a much lower temperature than other patches, and only about half light level at the maximum of noon, because the ice sort of remove some of that as well. There's a underwater cave. This has one of the higher iron concentrations early on, so that's good if you want to do like iron. Of course, a little bit warmer there. Then we have a more normal ocean top, the epipelagic, maximum sunlight there. Is there any others I missed before going to the kind of the coastal ones? We have all the actual coast. And I do believe there is a coast one we don't have showing up here as well. Just normal coast biome max. So anything that's on the surface will have max sunlight at this point. And we also have the tide pool, which is one of my favorites to go to, especially when I'm doing a cell that involves some amount of photosynthesis. I do believe there's like a river outlet of sorts that spawns sometimes, but we didn't seem to get that this time. Then there's also a migration manager, which can let you take some of your cells population, well, your species population, and change the amount you want to move over. So we'll send like about that much into this patch here. So next mutation cycle, well, next cycle, some of our species will be in this patch. I'm going to hit next now. I am going to be saying in this bottom patch for now. Okay. Just want to actually see if I can see anything about anything else. Hit global to see everything that's happened. Over everything. So, yeah, there's been no meteorite impacts yet. Also, I didn't mention, but there is so there's like runoff and upwelling, which will move compounds up and down, like these columns within the patches, and like kind of diluted. So I think it like this kind of messes with other like concentrations of things, and then upwelling will usually happen from like a bottom patch going up. I believe runoff generally is going to be occurring on like one of the near the coastal patches, and it'll then go into those patches, and then it can still kind of diffuse throughout the whole map eventually. Because normally like these upper patches won't have hydrogen sulfide normally, and you'll at times eventually start to see some hydrogen sulfide showing up in these higher up patches, even when they really turn to having like that one already does. That one has some. That one already has, but this one doesn't have any. But next cycle, we might see some hydrogen sulfide in that patch there, even if no like meteorite has hit it. And then because the nucleus was mentioned, it increases the storage by 2. It has a +9 osmoregulation cost. So with the normal membrane, the one that I'm using right now, it is about an increase of 20 ATP that you need to have just for this. Which, see right now, our usage is 9.5. I put this down, is 28.5. See, so roughly, I go for about 20 plus ATP production before I get the nucleus in, so I don't immediately die. Because it is a very tough organelle to use without proper preparations. Iron is also a pretty good ATP generation part. It was nerfed somewhat recently, but it's still relatively good. Alright. Local conditions are shown in this panel, the environment panel. Obviously, eyes have not evolved yet, but species may already rely on sunlight or temperature to generate food. If that's you, pay attention. Of course, because I can toggle this. This is because of the thermoplast, so I can look and see the different areas of blue being cold, red being warmer areas. Photosynthesis is inefficient during nighttime, so any cells that rely on photosynthesis need to have enough compound storage to survive the night. That was also added, of course, at one point, which was going to happen eventually, but it helped balance out photosynthesis, because before there was a day-night cycle, it was pretty broken. Of course, you can also see down here this bar that showed up during even the last gameplay. I just didn't point it out, but this is also a temperature gauge bar for the thermoplast and thermosynthesis related stuff. And also these various chunks throughout the map were added for to make things look more interesting, and they do change depending on what patch you are in. And there are also compound related chunks like iron, hydrogen sulfide, and if you're big enough, you can even engulf some of the smaller ones, and even eventually some of the bigger ones. And then you'll have a sort of you just have a nice little piece of rock generating one of the compounds you need. here again. Here. Oh, I already talked about the migration manager. Let's see. And now we go here. Yep. There is our species right there. And also let's see. Oh, yep. And we can now see there has been a little bit of hydrogen sulfide that has gone into this patch here. Alright. There are many paths up the evolutionary ladder, but here are some things to consider to get started. Focus on specialization to survive on one or more ATP sources so that you don't require many different resources at once to sustain yourself. I tend to branch out a lot, especially in the lower patches, because it's kind of easier, so I just various options. But you have seen some other gameplays, when I go to certain patches, I limit what I'm going to be using. Multi-step metabolism pathways are more complex to manage. For example, some organelles make glucose instead of ATP directly and thus need a second organelle to turn that glucose into usable energy. Resist the urge to grow larger as fast as possible. You don't always need to change what already works, as each part costs ATP to maintain osmoregulation. It's much easier to survive as a photosynthesizer, but eating other microbes is more exciting. One possible strategy is to stay very small and just head to the surface patches first before getting photosynthesis organelles. Don't overthink it. Trillions of cells die before one finds a useful adaptation. You can always load a previous save if you find a dead end. And I tend to just go ham though because that's just how I play. Now I'm going to start trying to boost this up to try and do the nucleus, because I do want to show, of course, some of the higher up features. Not higher up features, that is such a weird way to say it. But features of, like, talk about the multicellular features. And also, I don't want to use the cheat menu because I don't want to like mess with any potential tutorial stuff that could pop up. But I also think we're getting to the point where most of the tutorial is done at this point, except for like there are certain things I know that can happen where it'll pop up again. Yeah, I'm gonna use a tutorial. Obviously, if you do that, you'll no longer be able to get achievements in your game, but you can speed things through. I just want to be able to get things moving a bit faster. All right. Oh, and one species has gone fully extinct from the planet. And if you saw in the summary there, there was a meteorite impact here. It's a radiation impact. So this will dump some new compounds. It can be of pretty much any of these, and there's a generic one that just increases carbon dioxide. But this specific one is a radioactive meteorite. It will all meteorites impact all meteorite impacts will increase carbon dioxide, and then the different variants will spawn in different things. So this one will spawn radiation chunks, which is why it now has a radiation modifier that shows an actual value here. But you can also get iron, glucose, hydrogen sulfide, phosphate, and ammonia. Right, ammonium phosphate, which can add some more things in those patches. There's also volcanic eruption here, and another one here. Especially in these other volcanic events, if they get a lot of eruption events before species get in there, they can have a high value of their hydrogen sulfide. Alright, okay, alright, this is finally showing up. This panel down here shows a prediction of your future total energy gathered and population in parentheses. These numbers are from the simulation of AutoEvo. They don't take into account your individual performance, so in your current patch, the final numbers will be different than they would be from AutoEvo alone. Your species population decreases every time your cell dies, and it increases every time you enter the editor. But you should try to keep these numbers up even in patches where you aren't directly involved. You can view more detailed information behind the prediction by pressing the question mark button in the panel. Press it to continue. So this is just like the calculations of it. There's this niche thing, which is also I think tied to like some of the patch, like niches related things. They just use a name for it. I generally don't actually look that deep into it, but we do have a new part that's shown up here. It is a 55 cost part, the nitrogenase. nitrogenase. It does glycolysis. I've at least done that one so many times. I don't think I need to do it again. And also there's anaerobic nitrogen fixation, which uses 1.661 units of ATP to make 0.053 units of ammonia per second at 66.4% of nitrogen in your environment. Nothing else has popped up. I am going to we're almost, I think, about 20 over. Probably do a few more things in the next editor cycle, and then after that I'll try to get the nucleus present. Still only have these. There are some other buttons that would show up as well. They're just not present at the moment. Let's hit that again. All right. You can adapt your cell to different environmental conditions. Environmental conditions can cause negative and positive effects, so it is important to ensure proper tolerances are set when moving to new patches. Select the tolerance tab in the left panel to continue. So, tolerance editor allows changing the environmental conditions your species is adapted to. These include temperature and pressure of the patches you reside in. When moving to a patch you're unadapted to, there will be various negative effects. Adjusting the sliders to correct either the preferred conditions or increase the flexibility range for the new patch will remove these effects. The unsuitable conditions are shown in red. To become perfectly adapted and gain bonuses instead of negative effects, the flexibility ranges need to be reduced to minimal values while still staying adapted to the patch. The numbers will then turn green and grant positive effects. The trade-off with perfect adaptation is not being suitable for a wide range of patches. Planning before moving patches by increasing the challenge ranges can be a good strategy if you have some remaining mutation points to use before entering the editor. Try changing one of the environmental tolerances to close this tutorial. So a lot of times, even in the lower patches, I will actually go here and increase just the oxygen a little bit, because there will eventually be some oxygen within this patch, and given some of the parts, we lose that resistance and also growth order. I'll let you change the order in which different parts tend to go in. I will usually end up trying to keep the nucleus at the bottom just so it doesn't cause problems later on. Do one more. Make sure there's a bit of a nice bonus between the production and ATP usage for when I do the nucleus next editor cycle. And of course, if you're going to a higher up patch, increasing UV resistance will help you not die to sunlight, basically. Oh, and we can actually see AutoEvo is telling us nucleus next. This doesn't happen a whole lot if you directly follow AutoEvo at times, but it will tell you if you end up having enough room for it. After returning from the editor, your sister cell will spawn next to you. Restored compounds have been split with the sister cell so that it can also survive. Depending on the selected difficulty option, you may get additional free resources to top up your cell after exiting the editor. On normal difficulty, these bonus resources are only given if you're just changed to living in a different patch. Resources being split after reproducing makes it a strategic choice whether you want to immediately reproduce once it is possible or to play for a bit longer to stock up on resources to make your next life easier. I'm going to just level some of that up. Increase the iron I got. That, and just hit that to quickly jump in again. Of course, if we look down here at global results, we'll actually see now, compared to what we got here, a lot of other cells here, because things have split off a lot more. I'm seeing some spikes actually showing up. That photosynthetic cell went extinct, but there is that one as well. That individual died out. I think there's just a membrane change on that one. That one just appeared. We're about to get a nucleus though, so we're going to be having a real fun time. Alright. And of course, this is the compound balance display. It shows total compound use and production of all cell processes. This is a very important tool to check the effectiveness of organelles that do not directly produce ATP, as they will not show up in the ATP balance bar. For example, photosynthesis builds can be balanced with this display. There needs to be enough photosynthesis glucose production to have a positive balance for glucose in order to make a successful plant. Understanding that some organelles make intermediate products that only then get converted to ATP is a key concept in more advanced metabolic pathways. The storage lasting times underneath this display will also become important with advanced cells. So this will tell you generally how quickly these storages will fill up based on just the things you got here. Alright, of course, the nucleus. I will generally put it on the back of the cell. As you can see there, pretty significant increase in the actual osmorregulation cost there. But also, we now have a lot more things that have popped up and become available, such as the cilia, which allows for increased turning speeds, but it can also be modified into a pulling cilia to grab things around you and drag it towards you. And then we have, of course, more actual organelle variants of some of these. So we already have an organelle variant of the chemosynthesizing protein, which is the chemoplast. It does a better version of chemosynthesis, 0.294 units of hydrogen sulfide to 0.276 units of glucose per second at 33.1% carbon dioxide. And this one has probably changed its values from when I first said it based on potential change in carbon dioxide values. Although it should be noted that there is no longer the glycolysis occurring in this, so you don't gain ATP now when you place this. You only generate glucose, which is in part also kind of why this panel can become important. I also have a nitroplast, a variant on the nitrogenase, although right now this one also requires oxygen to utilize, so even if it replaces this, there is no oxygen, and as such, nothing is going to be done. There's the vacuole, which is good for increasing storage. You will see me use this a lot, especially with utilizing hydrogen sulfide, sending iron and glucose, because I can increase more storage of it, because even by replacing it normally will do a base increase in storage, but you can modify it for specific storage uses. There's also the melanosome. This is obtained by taking some damage from radiation. It uses 0.2 radiation units to create 35 ATP per second. It is pretty efficient, and it does give some resistance to radiation damage, but you'll still potentially end up taking radiation damage if you get too much. So it is a bit of a tricky style, and I would love to do a playthrough where I have just this, but it would be really difficult since also it is only an organelle part, which is also nice and black, a nice black organelle, which works well for radiation. Yeah, that is something I want to try at some point, but I feel like it's relatively difficult. Also, you'll now see that a lot of these will have not just the one increase on ammonia and phosphate, but two because of the way their sites tend to have changed around. So if it's a single hex, it'll still have the regular increases, but if it's doubled, it'll kind of double those values. There's a signaling agent. This lets you basically give commands to your the other individuals within your species. I often will utilize this even in later stages to, especially in the early multicellular, to have the other colonies get away from me, because you can sometimes get a little caught up inside of them. There is also the bioluminescent vacuole, which gives some resistance to oxygen and produces a bit of light. So it just helps increase oxygen resistance if you don't want to mess with the bar at all. But it only produces one light color so far, and there is still there's still discussions about ways to change it so that you can do more than just make bright light. There's also the endosymbiosis tab. Any species you have previously consumed can show up here, although I would always advise also checking the patch map to make sure that the species is present within your patch, because you don't want to click on a species that is not actually present. These all look like they're there, so And we're going to move on out. Yeah, so if you do need any more help, there is a menu in here called Help. I don't want to do that. And also zooming in and out, you probably already see me do that. I always zoom out so I can see more of what's around me. And you'll also see that at this size, I also have a much larger radius for actually absorbing materials. And usually this is also going to be the point where you start to be able to actually consume some of the actual rock chunks. Well, I've not discussed it yet. There is a sort of a sprint button. You will at times lose ATP, especially if you're a much larger cell. Also, I'm trying to go after this because this is the thing I have endosymbiosis with. So I want to be able to get it so I can work on getting it into a organelle. I'm potentially going to start dying because I don't have enough ATP generation. So the treatment, I'm going to just start kind of, that is not even doing anything with the glucose. Alright. I did just use the cheat menu to do that, but then just got to do what you got to do. And that one has the mitochondria for some reason already. Nothing of note in any of the patches. We now have a ferroplast. Pretty good. And I'll also add that there. You'll see they actually will show up as different things because they're different sources. Then also you can look at this undiscovered section to find the requirements to obtain different parts. Of course, there's two in here we likely will not be getting at all. The metabolisome, which is the precursor to the mitochondria, and the thylakoids, which is, of course, the earlier version of the chloroplast. There's a lot more in here because a lot of these are the organelle variants of the proteins we already have, and then a few other things as well. Of course, this has not increased because I did not actually consume any of that species. Of course, just not moving. I can probably just felt my glucose maybe a little bit. Like barely. Just hit menu here. And usually a common thing to be aware of is even after you get the nucleus, your population will drop somewhat over time. It is a very rough thing to utilize. I'm going for the polycylia so I can try to get endosymbiosis species. trapped. Alright. Now have hydrogen zone. And I'm going to go ahead and modify this. And we'll make our membrane more fluid. My main issue right now is I don't have any iron. So now we will actually have that somewhat completed. Trying to figure out how best to deal with the iron shortage I got at the moment. Also, the probably best way would be with more heat generation, in my opinion. Alright. There's some iron right there, so I'm going to go and grab that. And some hydrogen sulfide over there. So eventually, I will end up using vacuoles to increase the amount of storage I can have for these things, so I can hold more iron, more hydrogen sulfide and whatnot. Even more glucose as well, especially if I'm doing a plant. Right now, I would love to find a hydrogen sulfide chunk that I could consume. That was a pretty big cell I was able to eat there. That should help me for a decent while. Well, as you can see, the messages about not having a specific enzyme is the result of species that have an enzyme. Well, I have a membrane type that I do not have an enzyme in order to consume. I believe there we go, so yeah. hydrogen sulfide chunk. I'm going to attempt to consume that. Hopefully nothing gets hurt before I can. It's the strategy I like to use when I'm in patches where I can actually consume a specific chunk for something I need, because then I kind of just have it within my solid, and I don't have to go looking around for it until I end up running out of it. Ouch. Took a bit of damage there. And we can actually see there was another meteorite impact here. That one was a phosphate meteorite. Alright. Now we also have the binding agent, which I'm going to actually just do this right now. A strategy I always have to get to the early multicellular is have both a binding agent and the signaling agent, which can get within a single editor cycle. It's 55 and 45. This lets you call your cells towards you, and then of course you bind with B with a binding agent. Alright, so I'm now going to actually sit here. I'm going to have them move to me. I'm going to just sit with B active. And you can now see that this button has appeared. And I now basically control 2 cells. I now got a third one. And you are able to still move around like this. So don't think you just have to stand still. I tend to just stand still so it's easier for the other one to get to me. And put them into a pain matrix. Right, and now that that has happened, I can hit this, and we'll move on to the early multicellular. I can refer to that way since the stages after this are macroscopic and 3D environments. I would just refer to this as early multicellular. Alright, and then you will see on here it does show a little different now with the actual editor. Oh, gotta put that there. Alright, so yeah, I don't think there's any tutorials here, so once again, at this point you would have determined your general niche location, your general focus for your production, but you'll now be able to modify your cells some more. And you can see here you also have actually every single part you need that is available, so that is a funny quirk of this. So you can now, I could just throw on a chloroplast for some reason, even though I didn't earn any of the parts for it, or even a mitochondria. It's not going to really help me at this area. And also things are a lot lower. Here, there's a membrane tab. There are other buttons which I think now kind of appear. There will eventually be more reproduction methods. It's just budding for now. Of course, obviously the modification of your cell, that's still similar to just the normal editor, but cheaper parts. Then you can duplicate. And you now have a new cell type, which you can then, of course, modify. One thing I like to do a lot is change the color. Makes it very clear what cell you're working with, or at least what you're, or if you're modifying things for certain things. Like for this, let's say we modify this one. I also like to color code it as well. So let's say we did yellow because we want it to be a cell that focused on, where is the part? This. Like we just started throwing down a bunch of these to create a lot of glucose from hydrogen sulfide. Let me just move this to the back. And then gameplay wise, you now have to generate each cell with ammonia and phosphate, so you don't reproduce like before. You butt off a new cell when you have enough. So this is also where I will do the flee to get them away from me. You can see that one's connected there. You will see the bar there is actually filling up for the phosphate. It will fill up with ammonia as well when it has enough, along with the normal production amount. And now I'm just leaving a trail of hydrogen sulfide because I filled up my storage for it. But the chunk that I've consumed is still making it. And there we got another one because I had enough. And you'll actually see now this button to go to the macroscopic stages. You need a colony of 20 cells. Of course, in real life, the colonies would have been much more individuals, but gameplay-wise, pretty sure that would crash even some of the better computers if you had like hundreds or thousands of entities within a single thing that was being controlled. But yeah, and then obviously you want to fill the rest of this up to end of the editor cycle, so you can then do some more edits. Now you can see here what the change that occurred between like these cells and how they show it. Here is it's showing the sort of colony setup, and yeah, so that's pretty much all I have for now. I hope you enjoyed it, and I'll be making a normal video the next time I have a day off from my job. Have a good day, everyone.